Hello everyone and welcome to this video of the course Robotics. In this video, we are going to work on the example of controlling the speed of the robot using PWM. In previous video, we already seen how to interface a DC PO geared motor using L293D with Arduino Uno board. And in this video, we are not going to only control one motor, but we're also going to control two motors along with PWM. So let's get started with that. For this we'll be opening Arduino and we'll be writing Arduino code, and after that we'll be analyzing the output of Arduino code onto the robot. We'll also be looking at what are the parts needed to construct a robot, and we'll also looking at the procedure to construct the robot. So let's get started. Now we know that in this robot we're going to use two DC PO geared motors. Every motor contains two terminals, so on a whole we are going to get four terminals that we are going to use. So let's define the four terminals out here. Int M11 equals to, let's say I'm going to use it on PWM pins. So 5, 3, 5, 6, 19, 11 are the PWM pins. I'll be using 6 out of them. Int M12 equals to 9. Int M21, that's for second motor, let's say it is 10. And int M22 equals to 11. Int M22 equals to 11. So these are the four terminals that we'll be using to control our two motors. Pin number 6 and pin number 9 will be connected to L293D to control first motor, and pin number 10 and pin number 11 will be connected to L293D to control our second motor. So we are going to assume that our first motor is connected on pin number 6 and 9, that is M11 and M12, and the second motor is connected to pin number 10 and 11, that is M21 and M22. Let's define one more increment variable, that is int I equals to 0. Coming back to our setup, here we'll be first defining the pin mode of all the pins. So that will be pin mode of M11 will be output, pin mode of M12 will be output, pin mode of M21 is going to be output, and pin mode of M22 is going to be output. Thereafter, coming down, now let's say that we want to control the speed of motor in a way that we want to take motor to take 4 turns and come back to the same position, and thereafter increment speed and again take 4 turns. So we'll be writing code in which the motor takes certain turns and works in every turn. It works on a particular speed. So let's say that we want our robot to rotate. Let's say that we want to rotate the motors with the PWM speed of out of 255, minimum of around 180, and we'll keep on incrementing it after every 30 rotations. Or let us say that we can start from 150 and we'll keep on incrementing it after every 30 rotations, after every 30 values of PWM. So let us start with that. Let's define I equals to 150, and for I equals to 150, I less than 256, and I plus equals to 30. The meaning of this, that in every rotation I will start from first 150 and then go to 180 and then 210 and then 240 and then again come back after 256. It will come back to 150. So it will take certain turns. In every turn it will rotate with the speed difference of 30 bits. So that will be equivalent to 30 divided by 255 multiplied by 5 volt of differences. So let's get started with that. So first, let us say that we want our robot to go straight. For that, both the wheels should be into same direction. For that, we'll be writing digital right. For the first terminal, we'll make it low, and second terminal, we'll give it the value of around the analog value of around let us say I, that is 150 we defined. It means the first motor is going to rotate with the speed of somewhere around 150 divided by 255 multiplied by 5 volt, which will be somewhere equals to nearby 3 volt, which will be around 60% of its speed. And let's rotate the another motor with the same speed. So for that, we'll be writing digital right M21 comma low and analog right M22 comma I. And now let's say that with this speed we want our motor to go straight for around 3 seconds. So we'll be giving a delay of around 3 seconds. And now after 3 seconds we want our robot to take a turn. So in that case we'll make one motor switch on and another motor off. So for that, instead of M22, we'll be writing it 0 value. So let's do that. Digital right M11 as low and analog right M12 as I and digital right M21 as low and analog right M22 as 0. Now this is the command for taking turn, and let us say that we want our robot to take a turn for around 1 second. So we'll give delay of around 1 second, which will correspondingly give a particular angular turn. In next video we're also going to analyze that by hit and try method how to set a particular angular turn using delay and PWM in DC geared motors. Next, after taking a turn, let's say we want our robot to go straight for 3 seconds. So similarly we'll be writing digital right M11 comma low analog right M12 comma I digital right M21 comma low analog right M22 comma I. And for going it straight, we'll be giving a delay of around 3 seconds. Similarly, for again taking turn, we'll make one wheel on and one wheel off. For that, we'll be writing M11 comma low analog right M12 comma I digital right M21 comma low analog right M22 comma 0. So in this case the motor will stop and it will take a turn. Let's say we want to take a turn for 1 second, so we'll be giving a delay of around 1 second. So we're done with 2 turns. Let's say we want to add 2 more turns. So similarly we can make next the robot to go straight for 3 seconds after this turn. So for that we can write digital right M11 comma low analog right M12 comma I digital right M21 comma low analog right M22 comma I, and let's give it a delay of around 3 seconds. Next, again third turn. For third turn we'll be again programming in the same way. Digital right M11 comma low analog right. We'll keep this wheel moving up, so for that we'll be writing analog right M12 comma I, and for this stopping this wheel it will be digital right M21 comma low, and also analog right M22 comma 0. Instead of this you could also return digital right M22 comma low. That would also take it a turn. Next, after the third turn, let's say we want our robot to go straight, so for that digital right M11 comma low, analog right M12 comma I, digital right M21 comma low, analog right M22 comma 0 I, and give it a delay of around 3 seconds. So let's check it back how many times it's been. So we are starting again from this, in which robotic is going straight and taking first turn, again going straight, taking second turn, again going straight and taking third turn, again going straight, and let's see, we want to take it fourth turn, again go straight. So for that we'll be writing distal right M11 comma low, analog right M12 comma I, distal right M21 comma low, analog right M22 comma 0, and giving it a delay of around 1 second. And again, let's say robot go straight. So for that we'll be writing again the straight program distal right M11 comma low, analog right M12 comma I, and distal right M21 comma low, analog right M22 comma I, and give it a delay of around 3 seconds. And let's say finally we want to stop our robot for some time. Let's say we write distal right M11 comma low, and for this we'll have to stop both the wheels. For that we'll be writing analog right M12 comma 0, and distal right M21 comma low, analog right M22 comma 0, and give a delay of around 2 seconds for this. So this is the final code that we have completed so far. Let's save it up. And now compile the code. Connect the Arduino. Connect the Arduino. Check the ports into tools. When the port is connected, then you can simply upload the program. Now once program is uploaded, now we're going to check out the construction of robot, the connections part, and make it happen at the end. So we already seen the connections of motors along with electronic 3D to Arduinos, and in this way the electronic 3D input pins will be connected to pin number 6 and 9, 10 and 11, and other than that the power connection pins will be connected up. So let's check out construction of robot, and thereafter we'll see the output of this program.